Determinants of effective capacity. What factors determine the effective capacity of a system? So let's see. That would depend on the type of system or the type of capacity that we're talking about. So for example, for facilities, the location and the size of facilities are determinant of the effective capacity of that. For product and service factors, the variety, for example, of product or services that they are produced or offered are determinant of the capacity for that product or service factor. For processes, the quantity, the quality, and the efficiency, how fast they can produce or the process can be performed, is the determinant of the effective capacity. If you have human factors, the skills, the amount of skills, how skillful they are, that's the effective capacity for the determinant of effective capacity and the capacity for them. Also, in terms of policy factors, that could also be determinant of the effective capacity. The policy regarding overtime, for example, working overtime. What is the policy? That's a big determinant for the capacity of your system. If you don't have overtime working capability or allowances, if you're not allowed to work overtime, then that's going to restrict the capacity of your system. Also, for example, the shift, or what is the policy of your organization regarding sustainability or any other types of policy. So those are determinant of effective capacity. The operational factors, factors that are at the operational level, for example, scheduling. Do you have any scheduling restrictions? So scheduling is determinant. Also, the inventory and inventory management policies and inventory scheduling. Next is supply chain factors. So the suppliers that you have, of course, is going to be determinant of your capacity, effective capacity. Would they fail? How often do they fail? Or what is the quality of the supplies that they send to you? And also the transportation. What type of transportation do you use? Is it airline? Is it ships, cargoes? Is it trains or trucks? How fast they are, how efficient they are. So that's, of course, going to be a determinant of your effective capacity. Or it could be not related to your organization, it could be external factors. For example, the policies and the regulations that the local or state or international at the international level are set. That's going to impact the effective capacity for organizations. For example, the policies regarding the pollution standards. This is very tangible for cars, car manufacturing. It doesn't matter if it's a German car manufacturing, it's overall European car manufacturer or Japanese or American. We have right now at the level somehow a pollution standards that are popular at any continent and country. So these manufacturing have to consider that, and that's going to impact their effective capacity. Strategy formulation. Strategies and long-term plans are typically based on assumptions and predictions about future and the factors in future. For example, about the long-term demand patterns, what's going to be the demand in the market for certain products or certain services in the future. That's going to be, of course, impactful for your long-term strategy. For example, if you want to expand your capacity. Also, other factors such as technological changes, what technology is going to come up and what's going to be changing the world, what technology should be ready to actually adopt to and update and upgrade, and also assumptions and predictions about your competitor behavior. What are they gonna do? What product they're gonna introduce, or what service are they gonna introduce? New services, new product. What technology they are gonna use? What's going to be their strategy? So that's how you formulate your strategies based on these assumptions and predictions. Now that we have learned about capacity, the definition and terminology, and the measures of capacity and efficiency utilization, and also important factors and concerns in capacity and capacity planning, we can lay out the overall steps in capacity planning. The first step is to estimate how much capacity you require. So that's based on your estimation of forecasts of your demand in the market in the future. And after that, you also have to evaluate your current capacity. How much is your existing capacity, and find the gap between these two, what you have and what you want to have. So this extra capacity is how much you want to expand your capacity. After that, you know how much capacity you need. You have to identify the alternatives to meet that expansion of capacity. What is your alternative? For example, you could purchase several equipments, machines to produce a product. You might actually have different options and alternatives. Or, for example, one option as an alternative is to not produce it yourself, but to outsource it to other companies or overseas. So that's another alternative. So this is in this step you have to identify your alternatives to reach the uh, required capacity that you want to reach. Then after you identify those, you have to conduct some financial analysis to see the cost benefit of each of these options. You have to actually be careful about all of the aspects and assess the key qualities of issues for each of the alternative that you have. After this whole consideration from all angles, you're going to select the best alternative for the long term for your organization, considering the economic concern, considering the popularity concern, considering any other issue that is important for your organization. And after you select that, you're just going to implement the capacity expansion based on the alternative that you select. And the last step, but not the least, is to monitor the results of your action. This is very important a step in all decision-making processes and management processes, to monitor the results of your output, so that if you have made a mistake, you will learn from your mistake, or you actually make a corrective action to improve it. Capacity cushion. So one important step in capacity planning is to estimate the required capacity. That means the demand in the market, that you estimate in the future that you want to supply to, you want to provide to. But that's an estimation. And as we learned in the forecasting chapter, we know that our forecast is usually wrong. So because of this uncertainty in the demand and the demand level, the common practice is to have what is called as a capacity cushion. The capacity cushion is the extra capacity used to offset demand uncertainty. So capacity cushion is defined as the capacity that you want to have minus the demand. So this this extra capacity or surplus is to have an immunity against the uncertainty in the demand. So if your organization is a type of organization that or industry that faces a lot of uncertainty in the market, you are advised to have a greater capacity cushion. On the other hand, if your organization have a standard products and services, that means that you get not a lot of uncertainty, it's more standard, then you don't have to have a lot of capacity cushion. Smaller capacity cushion would do fine. So one of the important steps in capacity planning is to estimate the required capacity that you want to get to. And we're going to get a very simple and basic example here regarding the number of equipment and machines that you would need to expand your capacity. So for equipment, suppose that you're producing certain types of product I, and then you know the standard processing time for each product. And also, based on your estimation and your forecast, you have an estimation of the demand for that certain product. And also, you know the time horizon that you want to produce that many product to provide to the market. So based on this information, you can figure out and estimate the number of required equipments and machine that you have to purchase. As you can see from this equation here, N sub R, that's the number of required machines or equipment. To compute this is equal to the summation of Pi multiplied by Di, which is the summation of total processing time that you would need to meet the demand for product I. Suppose that you have K product 1, product 2, product K. And then you also know your time horizon, that's T here. So when you divide this total summation of processing time divided by your time horizon, this is going to give you an estimation of the number of required machines or equipment that you have to purchase here. So again, NR is the number of required machines, P sub I is the standard processing time for product I, D sub I is the demand for product I during the planning horizon, and T is the processing time available during your time horizon. So would make more sense if we do an example. So let's go ahead and do an example. Here is an example regarding the calculating processing requirements or capacity planning. Consider a department that works 1 8-hour shift per day for 250 days a year. You can see in this table the number of products that they produce. So this is a very basic and simple example. They only have three products here, as you see, product 1, product 2, and product 3. The second column shows the annual demand, which is the estimation based on the forecast that they have from the market for this product. Product number 1, the estimated annual demand is 400, and the standard processing time per unit of product 1 is 5 hours. So it takes 5 hours of processing time for the equipment to produce 1 unit of product 1. We have also this information for product 2 and product 3. For product 2, the estimated annual demand is 300, and the standard processing time per hour is 8. That means that it's going to take 8 hours of processing time for the equipment or the machine that they have to produce 1 unit of product 2. These figures for product 3 is 700 annual demand estimation, and the standard processing time is 2 hours. So now, try to solve this problem. Use the formula to estimate the number of equipment that this business requires. Let's see how to solve this problem. So according to the formula, what you need to do is N sub R, that's the number of total required machines for meeting the demand or the estimated demand in the future, is the summation of Pi Di divided by the total time horizon that we have. Pi is the processing time, standard processing time, that's in hour for producing 1 unit of product I, and Di is the annual demand. So what we need to do basically here is to multiply P1 by D1 plus P2 by D2 plus P3 by D3. So this means that 400 multiplied by 5, that's 2,000 hour processing time for product 1. Then 300 multiplied by 8 hours, that's going to give us 2,400 hours processing time for product 2. And for product 3, we have 700 multiplied by 2, that's 1,400 total processing time for product 3. So now we need to add these processing time up and then divide them by time horizon. So let's go ahead and compute the summation. The summation would be 5,800. So that's 5,800. I'm going to put it here. This is 5,800. Now let's compute t. What is the time, the total time horizon? Your time horizon is you have 250 days per year, and in each day you work 8-hour shift. So that's a total of 250 multiplied by 8. 8 multiplied 250, that's 2,000 hours. So this is 2,000 hours. So now we need to divide 5,800 by 2,000 hours. That's going to be equal to 2.9. So we would require at least 2.9 equipment. So basically we cannot have 2.9. We have to get at least 3 machines, right? So you always round up. Always round up. So this is what we need to do. We need to purchase at least 3 machines to meet the demand.